by nature, explorers. The same curiosity that sends us to the stars at the speed of thought urges us to go there in reality. And whenever we make a great new leap, we elevate humanity, bring people and nations together, usher in new discoveries and new technologies. So remember to look up at the stars and not down at your feet.
Right, hello everybody and welcome to Explore the Universe. Now this is going to be a little chat just about some random stuff, to be fair, about questions that I think about sometimes when I'm listening to podcasts or driving, looking up at the stars. I shouldn't really do that while I'm driving, but I do, always looking where the planets are. Just little fun facts, notions, quirky things, just stuff that might get you thinking and express yourself about our universe and what's out there. So to start us off, here's my question. In the beginning, nothing existed about 3.8 billion years ago. Something happened, funnily enough, and everything came from nothing. Matter, energy, time and space just appeared from nothing. Now this is a huge subject as it contains everything in the universe, all the planets, us, everything pretty much, every matter and everything. And is the origin and creation of me, you, stars, planets, the lot. But I want to talk about matter itself and its evil twin, antimatter. Now, perfection, as humans, we are obsessed with perfection. You see it all over the TV, on the radio. Find the perfect gift, get the perfect job. This will give you the perfect teeth. Wear that perfect dress. So we're obsessed with perfection. So when the Big Bang happened, it should have created equal amounts of matter and antimatter in the early universe. But today, everything we see, from the ants to the stars to the planets to the universe, is made almost entirely of matter. Antimatter particles are scarce now, but they share the same mass as matter. All that's different really is their electric charge is the opposite. So it's like plus and minus of a battery, I guess. Therefore, when they meet in space and touch each other, they actually destroy each other. So there's nothing left. So when matter and antimatter reach each other, they destroy each other. So when the Big Bang was probably the opposite, there was nothing and then something created maybe matter and antimatter. This is the opposite. So it's the destruction of everything back to nothing. But lucky for us, about one particle per billion managed to survive, as there seemed to be more matter than antimatter. Or we wouldn't be here, because I'm made of matter, and so are you. So the universe was created imperfect. So why are we so obsessed with perfection? When with perfection, we wouldn't be here. There would have been exactly the same amounts of matter and antimatter. They would have been brought together, destroyed each other, and there would be nothing. So really, the world is imperfect. The norm is actually imperfection. So let's be happy with the differences of the world and how people are and all that cool stuff out there. It's good to be different, and the universe tells us that. Now, is the universe trying to discover itself? That sounds a bit weird. But as we know, as I just said, everything was created in the Big Bang and in the universe. A huge cloud of gas that had a gravitational tug swirling together to create our solar system, the sun, thus creating the earth, thus creating life, which is us. So the universe created all of this. It created this nebula. It turned into the sun and our solar system. Life evolved on it, which is still the universe. And now we, as life, human beings, are now trying to discover what created it all and what happened in the Big Bang and where did we come from. Therefore, aren't we the universe searching for itself and asking the questions it can't ask because it isn't alive and sentient or ever like us. So there's a question for you. Am I the universe trying to discover myself? Is there a planet made of diamonds? 55 Cancri is a binary star system. It's located 41 light years away from our sun, and here lies an exoplanet, which just means a planet that's outside of our solar system, so it's one that's part of another star, not our own. Now 55 Cancri E being the designated planet letter, is an exoplanet twice the size of Earth, believed to be made largely of diamond. Astronomers said the rocky planet, called 55 Cancri E, was likely covered in graphite and diamond, rather than water and granite. So exoplanets that are created in a nebula with a higher carbon to oxygen ratio are more likely to be carbon rich, and it's suggested that these planets could convert the carbon into diamond and silicate if water is also present. This could also result in many planets being made of diamonds, not just one, helping fund any missions that can get there and mine it. There's a lot of money in a planet made of diamonds. So diamonds are an astronaut's best friend. Closer to home, the chemical reactions within Uranus and Neptune suggest to us also that they may rain diamonds too. So they're not made of them, but they may rain these small diamonds. They may not be exactly like the ones we have here on Earth, but that's yet to be proved. We haven't actually gone there and really studied them that well, not since like the 80s with the Voyager probes. So you never know. Diamonds could be out there for us to discover. Is space silent? So space is empty and is nothing really. So sound can't travel through it, as sound needs a medium to travel through, like air, water, stuff like that. So it needs to be able to travel through something. Space is nothing. But gravitational waves are able to, and we've picked these up using very sensitive equipment. And when two black holes merged in space years and years ago, probably millions of years ago, they created like a huge ripple. Not sure if it was a bang, but they merged and created a massive ripple that flew through the universe and passed through Earth. In fact, it did actually pass through us, and it made our atoms ever so slightly expand and then return. So we were actually slightly bigger and wider than we were before, and then afterwards we went back to normal, luckily. But it was so tiny, no one noticed, and our bodies didn't just sort of fall apart or explode. Now the planets and the sun also have radio emissions we can hear with special equipment, and it turns them into, well, it turns them into sound for us to hear. So you can't really hear radio emissions, but we can turn it into a sound so then we can hear it. So technically, yeah, it kind of works. So it kind of counts. Now the sun has almost like a heartbeat from what I've heard, and it sort of booms and stuff like that, and it's quite scary. Jupiter has a ghostly, strange, frightening sound when we hear it, as do some of its moons. Some of them are sort of almost cracking and things like that, and it's quite freaky to hear. So if you can go on the internet and have a look, find out what space sounds like. It's scary. What are neutron stars? We believe they are one way a star can kind of die. So you've got a high mass star, its core collapses at the end of its life, and a supernova goes boom and blows across the universe or the solar system. This compresses the core past the white dwarf star density sort of stage and onto that of an atomic nuclei. So it's quite weird to understand, and I'm not a physicist, but that's what it does. It's obviously so immense and there's so much gravity, it pulls it past the white dwarf star and crushes it into an atomic nuclei. Now what's left of the star spins rapidly because of its physics and what nuclei do, atomic ones, spins really, really quickly, and they can spin at around 716 times per second. I think that's the fastest one that we've discovered so far. I think they can say it can go from 60 times to 716 times per second, which is crazy amount of spin. It would make me sick. I'd get sick on the teacups, let alone that. We wouldn't be able to make this out with our eyes, probably even 60 times per second, because it would be spinning too quick for us. Now these stars are the smallest and densest things we know so far out in the universe, and a teaspoon of one would weigh in at 4 billion tonnes. You're not going to get that into your cup of tea. Space welding. Now, did you know that if you touched two pieces of metal together in space, they would bond and be permanently stuck together with nothing else added? This is called cold welding. On Earth, there's air and water separating the pieces, but in space, the different pieces of metal don't actually have any way of knowing that they're separate. So when they're put together, the lumps just join together. So that'd be quite complicated for building in space, or perhaps even hammering a nail. It would just bond together. So I imagine NASA probably use special tools that don't do this, maybe with plastic and things like that, who knows. So metal automatically bonds with metal in space. Polaris is the North Star, right? Yeah, at the moment, with the Earth's axial tilt, it points almost perfectly north towards Polaris, which is lucky for us Northern Hemisphere peeps, because we can use it to navigate and find our way. But it hasn't always been the case. Earth kind of wobbles by a few degrees as it spins over time, so in around 13,000 years it will no longer be the North Star. The big bright blue star Vega in the constellation Lyra, which is the harp, will be. That would probably be kind of better because Polaris isn't that bright, Vega is really bright, so having that as the North Star, even better. It's believed that in 3000 BC it was the star Thuban in Draco, the dragon. That was the North Star. I think that's quite faint from what I've seen. Draco isn't a really bright constellation. And then back in 26,000 years time later, Polaris will be back to its original place as our North Star. So yeah, it's the North Star at the moment, but it changes. Does time change in space? Now this is a difficult one. Now they found out that when they put satellites up in orbit around our planet, they kept on slowly saying the wrong time. It seemed that their clocks were like slowly getting faster because they're slightly further out from the mass of the Earth. Now this is because space-time isn't flat, it's curved, and it can be warped by matter such as a planet, the sun, or a black hole. The more mass, the slower time goes because it's bent. So if you wanted to travel to the future, go and visit a black hole for a while, then head back to the Earth, and voila, you'll be in the future Earth. Although it's not going to be good for aging really, because the stresses and exposures that astronauts experience during their time in space, things like isolation, microgravity, high carbon dioxide levels, cosmic rays, actually accelerate telomere, which shorten, and then that affects aging. So it shortens the aging process, so you actually age worse. Now, the telomere I've read are like protective plastic clips on the shoelaces, but for our DNA. So it actually affects our DNA, and although you might, time might go slower, you're going to age a lot more because of all these things in space. Our sun is yellow, right? Our sun emits all the colours of the rainbow, more or less evenly, and in physics they call this combination white. That is why we can see so many different colours around us in the natural world under the illumination of sunlight. And we see rainbows when it's refracted by water in the air when it rains. Now the sky is blue because our atmosphere scatters this wavelength of light, creating the blue looking sky. It also turns our sun yellow when we look through it. Plants are green because that is the colour they reflect, not absorb. Same with any other colour really. So you're not seeing its colour or the colour of the item you're looking at, you're actually seeing the colour it reflects. So you see black if it absorbs all of the colour wavelengths, and white if it reflects them all. So in space, our sun is actually white. It's our atmosphere and us looking through it that turns it yellow. So next time someone asks you to draw the sun at school, just draw a circle, don't colour it in on a piece of paper. Job done. How far can we see? Now, if you have a good non-polluted night sky, you should be able to make out a faint smudge that is the Andromeda Galaxy, which is 2.537 million light years away. This is the farthest object you can see unaided, but you are seeing it 2.537 million years ago. It's taken that long for the light to reach us. Now, Proxima Centauri is 4.3 light years from Earth and is the closest. So even when you're seeing light that left it was 4.3 years ago. The furthest thing from Earth to travel across the universe is radio waves, which since they started transmitting have travelled maybe 120 light years, although they might be pretty faint to have actually travelled that far. So at maximum, any aliens out there that are listening would hear us how we were back in the 1900s. Hubble has managed to look right back to some of the earliest galaxies created after the Big Bang, around about 32.1 billion light years. So that's the furthest we can look with the equipment we have. But just with your eyes, 2.537 million light years, Andromeda. That's quite far. Is life out there? Now, the Fermi Paradox, named after an Italian-American physicist Enrico Fermi, is the apparent contradiction between the lack of evidence for extraterrestrial civilizations and the various high estimates for their probability. So the probability is high that there is something out there, but there is no evidence that we found so far that there is. That's why we're looking at Mars and stuff like that. So there's an estimated 125 billion galaxies outside our own. There are more stars than sand on Earth, with on average 100 billion stars per galaxy, meaning that there are about 1 billion trillion stars in the observable universe. And this is very estimated, I must add. It's got to be very estimated. We're finding more and more planets outside of our solar system around these stars, and we know one of these planets contains life, Earth. So at least one planet out of 1 billion trillion stars and all the planets around them has life. Now, using something called the Drake equation, which is complicated, but it's where n, the number of civilizations in our galaxy with which communication might be possible, the average rate of star formation in our galaxy, the fraction of those stars that have planets, the average number of planets that can potentially support life per star that has planets, the fraction of planets that could support life that actually develop life at some point, the fraction of planets with life that actually go on to develop intelligent life or civilizations, that's us out then, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space, and the length of time for which such civilizations release detectable signals into space. Yeah, that's on the screen for you, so you can work that one out. So in my estimations and how I like to think, even 1 in a billion is quite a high number. Thinking of how many stars there are out there and then how many planets are possibly around those stars. So with many of these stars and their planets being much older than the Sun, which is our Sun, if the Earth is a typical, you know, Earth and Sun, some may have developed intelligent life long ago because there's loads of other stars out there like our Sun that, you know, are a lot older. So some of these civilizations should by now have developed interstellar travel, a step that humans ourselves are investigating right now and are getting close to doing, hopefully. So even at a slow pace of the currently envisioned interstellar travel, the Milky Way galaxy could be completely traversed in a few million years. And since many of the stars similar to the Sun are billions of years older, the Earth should have already been visited by extraterrestrial civilizations, or at least their probes. Not talking about where they go. However, there appears to be, so far, no convincing evidence that this has happened. So where are all the aliens? Strange moons. Our moon is rather big compared to its orbital planet us. The planet of us, our size planet, compared to the sun, is actually, the moon's pretty big compared to us. But there are some weirder lumps of rock out there. This moon of Saturn is mainly made of water ice, but what's special about it is it has two contrasting colours. It's very dark with a slight reddish colour on one part, while its other is very bright. The dark area is one of the darkest terrains in the solar system. Its origin is unknown. It could be composed of some sort of dark material that was swept up from space, or it could be something that flowed out from within the moon. We don't really know. All we do know is it looks quite cool. Another strange moon of Saturn is Minimus, which upon discovery, after the film was released, funnily enough, looks just like the Death Star from Star Wars. So we hadn't seen this moon before. The film came out, we sent some probes out there, then we discovered it. So it is a giant impact crater about 81 miles across, and whatever made it nearly fractured the entire small moon. You can see these fractures, and they're actually seen on the opposite side of the moon, and they've been created by the shockwaves that have travelled through the moon's core on impact and then pushed it out on the other side and fractured it. So the Death Star is real. Also within Saturn's rings, again, lies the very strange Pan. It's the innermost moon of Saturn. It's small and walnut shaped. To me it looks more kind of like a flying saucer, but you know, that would start people saying it's an alien ship. It's not, it's a moon. It orbits within a gap in Saturn's rings, so it's within the A ring, because all Saturn's rings are made out of different, you know, A, C, B, D rings, so we can actually tell what they are. So it's going around in there, and it's what's known as a ring shepherd. So it's responsible for keeping the gap free of all the particles in the ring. So it kind of like collects them all up as it goes round and round. That's why it's called a shepherding moon. It shepherds all the particles, leaving a nice gap behind it. So that's some of the quirky, strange and weird things in our universe, and I hope you enjoyed those random ramblings, facts and crazy notions that our universe has created for us to ponder. Clear skies, and remember, there's a billion worlds in your back garden.